right, so we're into 5-1, which is order of operations. Really important part of algebra. If you are not calculating your numbers correctly, then anything past that point is going to be incorrect. So really important for us to get a handle on this and kind of know what we're talking about. So, a variable. So a variable just represents an unknown value. And we show that shown with a letter. So when you were younger, they would put a blank 4 plus blank equals 6. Now we just swapped out the blank space for a letter. So 4 plus x equals 6. Okay, that means the same thing. So the number is the value of the letter. Okay, so that would be like x equals 2. Okay, an algebraic expression. Sometimes that's called a variable expression. So that's an expression that includes, that. At least one variable. So at least one letter is going on. Maybe 2, maybe 5, but at least one. Hey, Chuck, did you want to write these notes down? Okay, evaluate. So you're going to see things that say, like, evaluate the expression. That's fancy lingo for figure it out. That's all it means. Okay, evaluate. So we're going to substitute, another big word in math and algebra specifically, substitute a number for each variable and find the answer. When you have an algebraic expression, that's not the same as an equation. Equations always have one specific symbol in them that expressions don't have. Can you think of what that might be? Think about the word equation. Rachel, what do you think? It has an equal sign, right? Equations have an equal sign. Expressions don't. Okay. So if I were to give you this, evaluate expression when n equals 3. What if we had n minus 8? And over here we'll do 6n plus 7. So for each one of those, I'm going to, if I know that n equals 3, I'm going to plug it in here for n. So what's my n value going to be now? 3, right? So instead of n minus 8, we can do 3 minus 8. And what's 3 minus 8? Negative 5. Beautiful. So it has an actual amount, right? What if I plug in the 3 over here? Is it 63 plus 7 now? No. What does that mean? 6 times 3, and I don't want to see any x's anymore for multiplying. We don't want that anymore. We want parentheses. Okay. And then 6 times 3 is what? 18 plus 7, which would give us 25. Good. Okay, so a power is an expression that represents repeated multiplication of the same factor. And that can be a number or a variable, or an expression of a variable. It can be anything. So really important to remember. So if you have 5 to the third power, that's how we say that. If it's a 2, we say 5 to the second power. We usually say 5 squared. 5 to the third power, or we call that 5 cubed. Anything past 3, we just say whatever power it is. So 5 to the 4th, 5 to the 25th, 5 to the 1,000,003rd, whatever. Okay? It's really important to remember this does not mean 5 times 3. It means 5 times itself 3 times. So when you figure that out, you can break that down. So 5 times 5 is 25, times another 5 would give you 125. When things grow exponentially, they grow really, really fast, or they decay really, really fast. Okay? Much quicker than if something is linear. Okay, so if I give you a couple of these, I want you to write both of those expressions both in words and as a product. So do that now. So this would be 4 to the third power and mathematically, what does it mean? 4 times 4 times 4. So you can write that like this, or with parentheses in between. It's easier with the dots in between. What about the x with the 2? X to the second power, more likely x squared. Okay? And it means x times x. Okay? So how many of you before, when you've seen order of operations, you've seen PEMDAS? Probably everybody. I'm way over PEMDAS. We're shortening it up to GEMS. Okay? So, in PEMDAS, the P used to stand for parentheses. Now it's going to stand for grouping. Because there are other ways that grouping happens besides just parentheses. It can include parentheses, but it also includes brackets, absolute value, actually square root symbols. It can include lots of things, but not just parentheses. So it's just kind of incomplete with parentheses. Okay, second one is going to be exponents. Okay. So in PEMDAS, we would have the multiplication and division together. That's what the M and the D stood for. So here, we just shorten it up, but it still includes multiplication and division. Division. Okay. And you're always going to be completing that left to right. Just like when you read, you're reading left to right, you read your number expressions the same way. Okay? And the S is going to be subtract and add. Once you're down to just addition and subtraction, it makes no difference what order you're doing that in. You're just combining integers, which is exactly what we have been doing, right? Okay? So you must calculate in this order. Must. Okay? Really important. All right, we good? All right, let's try the first one at the top. No variables in this, just strictly numbers, okay? So, what's the first thing that I need to do? The exponent, right? I need to do the exponent first. So what you can do with each of these is just swap out another number. You're making change. So what's 10 squared? 100. Good. Means 10 times 10, not 10 times 2. Now what do I have to deal with? 4 times 50, which is what? 200. Excellent. 25 doesn't change yet, right? Okay, now you're just going to shorten that up and calculate. So what's 200 plus 100? 300 divided by 25. Now here's an easier way to figure that out. Isn't this the same as 3 times 100? Okay, how many times does 25 go into 100? 4 times 3. 12. Okay, so all of that mess gets right down to 12. All right, so what happens when you have more than one way to group things? You have brackets and parentheses going on. What? It's not even necessarily parentheses first. You start from, think of it like a microwave. Microwaves cook from the inside out. You need to work from the inside out. So your most inner grouping, whatever you have, that's what you need to deal with first. Okay, so we're going to start with this. And when you work with these, if you need to highlight them so you know which one you're going to do first, that's fine. Okay, so first thing I need to do is get that shortened up. What's 7 minus 9? Negative 2. And then I have to do what? Now I need to apply that exponent. Okay, so the rest of this hasn't changed yet. Now be careful. What's negative 2 squared? Positive 4. So now we can rewrite this. 9. I've got the 30. This whole thing shortened up to just 4. So 30 minus 4. So already that's a lot easier. Yeah? What's 30 minus 4? 26. You can change that to parentheses. You can leave it as a bracket. It doesn't really matter. And now, are we multiplying that, adding that? What are we doing? Multiplying. Good. So, what is 9 times, let's do this. What's 9 times 2? 18, and we're going to add a 0 because that's in the tens place. What's 9 times 6? 54. Good. Add them up. So 4, so 234. Good, good. When it says evaluate each expression, what am I going to do with that x equals 8? What am I going to do? Plug it in, okay? I'm going to hit pause. You plug it in, and we'll come up with it. So, Ashley, what am I plugging in for x? Okay. And the way I'm going to do that is like this. Okay, use your parentheses. So what part of that do I need to calculate first, Ash? The 8 squared. I've got to get that exponent out of there first. So tell me what I can swap out 8 squared for. 64. Okay, so now I'm multiplying that by 64 plus 7 minus, what's 4 times 8? Okay, so now I've got to get 3 times 64, which is what, 192? So that's 192 plus 7 minus 32. So let's do this the easy way. What's 192 plus 7? 199 minus 32. What's 9 minus 2? 9 minus 3, 6, and 1 minus nothing. So the correct answer should be 167. But there is potential for error over here. That's what's going on. My guess is that if you got a really big number here, I'll tell you the most common mistakes. Multiplying the 3 times the 8 first, and then squaring that. Really common. Don't do it. Get your exponents out of there first, always. Okay? So I can see where that one happened. This one, I think somebody probably added 32 instead of subtracting it would be my guess. Okay? All right, we're going to have to do a part 2 to these notes. So. Oh, you know...